We'll be talking about parallelograms. So starting with our definition of a parallelogram, it is a quadrilateral whose opposite sides are parallel. Again, a parallelogram is a type of a quadrilateral whose opposite sides are parallel. So if you can see there, the side at the top and the bottom, they are parallel, and the two sides na sa kilid are also parallel lines. Showing you, you have the line segment AB. This line here is parallel to the line segment CD or to the side CD. Okay, so you can see, kanang nag-slant na to diha vertically. And we have also segment BC horizontally and segment AD. They are also parallel, Ngano parallel? Because if you are going to extend these two sides or these two segment here, if you are going to extend this one, there is no possibility that they are going to meet. So one important characteristics of a parallel line or parallel lines, if you are going to extend this, going to the left and going to the right or up and down, they will not meet with each other. Okay, so mo lang gitawag siya nga parallel sides or parallelogram, because the two pairs of sides are parallel. And the symbol, the symbol is a small figure of a parallelogram. So if you can see there, kanang color blue figure, it is the symbol for parallelogram. So instead of writing the word parallelogram, you can just use the symbol, this one. This is the symbol for a parallelogram, Alright, so going back to our discussion on quadrilaterals. So quadrilaterals has three categories, or types. We have the kite, the parallelogram, and then trapezoid. Alright, now so for today, we're going to discuss more on parallelograms. Okay, and basing on our chart there, you can see that a parallelogram is also divided into rectangle and rhombus and square. Okay, so you can find there sa ato chart that there are three types of parallelograms: the rectangle, the rhombus, and square. So we will be discussing one by one of each parallelogram here: the rectangle, the rhombus, and square, and their special characteristics or and some theorems that we can use in proving some geometry problems. So in naming parallelogram, you can just use the four vertices of your figure. So in our figure, you can see parallelogram ABCD. Normally we are going to use, or we are using the English alphabet, the letters in the English alphabet using the capital letters. You can just use the capital letters. So that's why in naming your parallelogram and even naming other quadrilaterals or any polygons or geometric figures, we are actually using the English alphabet, the capital letters in the English alphabet. So in naming this kind of parallelogram, for instance, you can just say parallelogram ABCD. You are just going to use the four vertices of your parallelograms. Okay, kanang vertex diha, kanang end point kumbaga, okay, so kana siyang red color nga dot there. Okay, so you can start from any one vertex, but you must continue in a clockwise or counterclockwise direction. So if you are going to say this parallelogram, you can say this is a parallelogram ABCD, okay, or ADCB. Or you can start with B and then clockwise or counterclockwise. So that is your the name of your parallelogram. Okay. Moving forward to our basic properties of parallelogram, there are four basic properties of all parallelograms. So these four properties are applicable to all kinds or types of parallelograms, be it a rectangle, a square, or a rhombus, right? So these four basic properties are or have to do with the angles, the sides, and the diagonals, okay? So these are actually the basic properties that you have to remember in every time that you encounter parallelograms, because these properties and even definitions can also be used in proving some geometric problems, especially in proving congruences, right? So you can use the definition or the properties. No, if you are familiar with the properties, with the basic properties or with the definition of a parallelogram, then there's no difficulty na, no, or dili na ka maka-experience, you cannot experience difficulty in proving congruences. Again, these properties have to do with the angles, the sides, and the diagonals. So how about it? So unsa man di ang angles, unsa man di ang sides and diagonals of these parallelograms? So starting with the opposite sides, okay, starting with the sides, we have a theorem there that states opposite sides of a parallelogram are congruent. So we can see on our figure, you have two pairs of the same symbol there, kanang two parallel vertical, no, kanisang color red. Okay, meaning that line segment or the side BC is congruent with side AD, no? The bottom, the top and the bottom sides are congruent. Then we have also two parallel sides here, the segment AB and segment AC, they are also congruent. Okay, so it states there that opposite sides of a parallelogram are congruent. So that's one theorem, no? Meaning, again, AB is congruent with CD. Okay, you can find there in our figure, no, as shown on screen. And AD is also congruent with BC. Okay, so when we say congruent, they can also have the same measurement. Okay, so they can have the same measurement. So if AB is 7 units, so let's say for example, AB here is 7 centimeters or 7 inches or generally 7 units, we can also say that segment or the side CD or side DC is also 7. Okay, so kanang blank diha, this one here. So you can supply this one, you can fill in the blank there. That segment CD or DC is also 7. All right. Now on the part on our angles, now for our angles, one pair of opposite angles is angle A and angle C. So when we say opposite, you know what is opposite, no? It is just the kanang atbang niya, kumbaga, no? Manang opposite niya. So kung ang angle A is naa sa ubos or kanang sa sa ubos, then angle C is its opposite angle, kanang naa sa taas, that's angle C there. And then the other pair is angle B and angle D, no? So these pairs of angles, okay, are actually congruent also, no? So that's why another theorem states that opposite angles of a parallelogram are congruent. So again, when we say congruent, the measures or the measurement of these angles, for example, on our figure there, angle A and angle C are congruent with each other. So if your angle A is 72 degrees, then your angle C is also equal to 72 degrees. So that's why you can see there that they have the same symbol, no, kanang na duha ka line or duha ka curve there. Then for angle B and angle D, they're also congruent. They are opposite angles. Then they have the same measurement. Alright, so that's another property, no, of parallelogram. So that's why if your angle A is 75 and angle B is 105, then the corresponding opposite angles of these two angles are also equal to 75 and 105 respectively. Alright, so if angle A is 75, then the opposite angle of angle A is C, so angle C is also 75. And then if angle B is 105 degrees, then the opposite angle of 105, which is angle B, is the angle D. Then angle D has also 105 degrees, right? So I hope that you can still follow, no, our discussion here. Alright, so moving to our next property, which is the consecutive angles. When we say consecutive, meaning nagsunod, no, on our term or in our dialect, consecutive would mean nagsunod siya. So in each angle is consecutive to two other angles, be it you can move clockwise or your direction is clockwise or counterclockwise. So on our figure there, A, right, A is consecutive with B and D. So if you're going to look, no, on our figure there, see, A is consecutive with angle B, and at the same time, it is also consecutive with angle D. No? So depending on your direction or your rotation, kung clockwise or counterclockwise, right? So again, each angle is consecutive to two other angles. So let's say, for example, for angle B is also consecutive now with two other angles, which are angle A and angle C. For angle C naman, it is a consecutive, no, to two other angles, which are angle B and angle D, and so on. All right? And the last, no, basic property of a parallelogram, the theorem that states about the consecutive angles, it says that the consecutive angles in a parallelogram are supplementary. Now, if you can still recall what a supplementary means, it means that if you're going to add the two measures of these angles, this is equal to 180 degrees. Now, when we say supplementary, the sum of the measurement of, or the measure of the two angles is equal to 180 degrees. So, let's say for example, if angle A here is 75, then we can actually get the measurement of angle B, no, by just subtracting the measure, right? By just subtracting the measure, since we know that A and B are consecutive, and the theorem states that consecutive angles in a parallelogram are supplementary. And we know that when we say supplementary, the sum of the measure, no, when we say sum, i-add nimo, no, addition na siya. Then if you are given the measure of angle A, then we can get the measure of angle B by just subtracting 180 from the measure of your angle A. So let's say for example, angle A is 75 degrees, no? So therefore, angle B is 180 minus 75 degrees, and that is equal to 105 degrees. Another property of a parallelogram is that about diagonals. Now, unsa maning diagonals? This is the line, no, that you are going to draw from one vertex to another vertex, and it will unsa tawag na siya? It will bisect, no, the parallelogram, okay, at the center of the parallelogram, of course. So let's say for example, so you have their parallelogram ABCD. If you are going to draw a line from vertex B to vertex D, okay, so you can see there sa a figure, no? So this is diagonal BD and diagonal AC. So what about it? No, unsa man di ay ang property, no, when we say about diagonals? That diagonals are segments that join non-consecutive vertices. So wala nagsulod nga mga vertices. So for example, in this diagram, the only two diagonals are segment AC, okay, this one, and segment BD. Diagonals are segments that join the non-consecutive vertices. So when the diagonals of a parallelogram intersect, they meet at the midpoint of each diagonal. So let's say for example, diagonal AC and diagonal BD intersect and at the same time meet at the midpoint of each diagonal, meaning the point P, not P, point P there as in pineapple, it is the midpoint of diagonal BD, and at the same time it is also the midpoint of the diagonal AC. So when we say midpoint, it divides, no, the segment, for example, AC or BD into two sides or two equal parts. So let's say for example, diagonal AC is and diagonal BD intersect each other, and we have also there the midpoint P, meaning BP and PD, no, they have the same length. AP and PC has also the same length. So there, no, so P is the midpoint of AC and BD. Therefore, they bisect each other. So AP is congruent to PC, and BP is also congruent to PD. And again, when we say congruent, they can have or they have the same measurement or length as well. Are not congruent. So you cannot tell that AC is congruent to BD. But there are some instances, of course. But in this case, we cannot tell always. No, you cannot tell always that all parallelograms have congruent diagonals. No, although there are some types of parallelograms that if you're going to draw a diagonal, no, you can have two congruent diagonals. So later, no, we can tell.